In the past, servo tuning used to be somewhat black magic or voodoo art, but thankfully with the 1S, Omron has made servo tuning really straightforward. Now, rest assured, if you like really getting under the hood and getting into all the details, we have advanced tuning that lets you into all of those parameters, but for now, let's take a look at the easy tuning. Here's a project that I have, and all I've done so far is to configure my EtherCAT network and assign my motion axes. So to get into tuning, I just right-click on the servo drive and then select Setup and Tuning to open the Setup and Tuning portal. Now in the tuning area, I actually have 3 different methods for tuning, but I kind of like hitting the Easy Tuning button, and that's going to start me into the tuning process. So the first thing I need to do is figure out what tuning features I want to have easy tuned, and I just recommend selecting the simple method. It's going to enable nearly all of the tuning features, things like inertia ratio, handling vertical loads, and even filtering out resonant frequencies. So after that's set, I enter a motion profile to use for my easy tuning, and I typically just enter a profile that's fairly representative of a typical move for the application. So the lead screw I have here only has about 3 revs worth of travel, so that works great. But let's run on the speed up to 1500 RPM, and we can keep that same 50 millisecond accel decel time. So now I need to tell it how to know when it's finished doing the easy tuning. And a little secret, a lot of people use these default values and get really fantastic results. But I'll set my target stabilization time to 10 milliseconds and then my position window to 800 counts, which is less than 1/10,000th of a rev with these 23-bit encoders. Now I can move on to actually running my easy tuning. When I hit start, the drive launches the easy tuning sequence. It starts with low gains at first, and then continues ramping up the gains. And tuning has gotten a lot faster because the gains are increased depending on the measured stabilization time. If it's still really long, the gains get moved really quickly. But as I get closer, the gains just sort of get tweaked to try and dial in that performance. And you can see that with each iteration, the stabilization time keeps dropping and dropping until it dips below the target value that I set on the previous page, and that's when it knows that it's finished. And tuning my servo was just that easy. So with my gain set, now I can take a trace of the motion now that it's tuned. And then finally, the last page shows a big table of all the tuning parameters, and I can save them to the drive. Another really great feature is that I can actually copy those same tuning gains over to other drives in my project. So if I have multiple drives that are driving identical mechanical systems, I can actually tune just one and then replicate those tuning values over to other drives. And with that, I click Finish, and my servo is tuned and ready to go. So head on over to omron247.com to learn more about the 1S tuning features and how the 1S can improve your machine performance.